Hello everyone, welcome to Python tutorials, and in this lecture of lecture 9 we are going to learn about inheritance and its other function in OOPS. So what is inheritance? Inheritance is a way of creating a new class from existing class. Now we have learned about class in our lecture 8 in OOPS. Now we'll move further to inheritance. Inheritance means basically creating a new class from the existing class. The classes we made in the oops chapter, we are going to make the another classes from those existing classes only. So we are going to move into our VS code, then we are going to open our folder, as I have already made folder of Python 9. So our 9th lecture is inheritance in oops. Now making a file to let you understand what inheritance is. Let's understand this with an example. I will create inheritance dot. So inheritance.py is created here. Now if I create a class here, suppose class employee, and then def show self print f string, the name of, or the name is self dot name, and salary is self dot salary, just like that. Let's create a class programmer here. So I'm creating two classes here, employee, and then in employee I will create programmer. I have done it wrong here. This is how it's done, not parentheses will come here. Now def show self, and now I will print uh, the name is self dot name, and salary is self dot salary, just like this. I'll create another function. Now here I will show language. This is the function. I will create it with self, then I will print the name is self dot name, and he is good with self dot language, and here language. So just like that I will write it. And now if I want to add an instance attribute here, and suppose I want to extend this, so this is a very good you can say way to create and work on them. And keep one more thing, which is company and name. If I do hit here, company is equals to suppose ITC, and here suppose company is equals to ITC info tech, just like that. Now I'm going to make these objects here. A is equals to employee, like this, and B is equals to programmer, and then I will print A dot company and B dot company, just like that. Now if I will run this, I will get here is I am getting B equals to programmer, as name programmer is not defined. So now I have written everything here. As you can see, I have made objects here, then I've given the attributes here, then I print it, and then I am calling the function here. So how will them react? So if I want all the methods and instances of suppose this class, one of the class here, so so I'll copy it down. But here in class employee there is only one method. Now if the show is there, and if suppose there were 50 more methods, just like the show here, show function here, so we have copied them, we would have copied them down and make another class. But if I create classes by copying them, one of the biggest challenge for me would be uh, the change. Suppose if suppose if I want to change something later on, so I will have to make these changes in that particular class. So I have then to change to all the classes, and that process will become more cumbersome. And also with cumbersome it will also be error prone, because I will make mistakes when I will copy the methods one by one, and then I will change those methods again. So there will be some mistakes also in changing them. That is what we have to do. So in print name self dot name, so then I'll have to change it here as well. If I would change make change in here, so I have to change make the changes here as well, because if I copy the file or copy the methods here, because I would want to keep that show message the same here. That means I want to keep it inconsistent with within classes. So this is not a good way or a better idea to work. Instead of doing this, let me just comment it out here, just like this, and this this and this. Now I have commented them out. So I'll use here in inheritance here. I'll say that see the class programmer from which I am inheriting the another class which is employee. Means whatever there is inside this uh, programmer, which will be there also in employee. There are several other things as well that I want to add and that I want to delete. I'll show you how I will inherit the programmer and inherit the employee to programmer. So we will create class programmer employee, just like that, and then I will write company is equals to, and I will copy this company, just like this, and then I will print no, I will firstly make a function here, def show self, just like this. Now I will print this. The name is self dot name here, and he is good with self dot language, just like that. And when I will run this, now I have written self wrong here, write it in small words. Programmer object has no attributes or language. Now as you can see, everything is got printed here when I wanted this. So I will comment this programmer here again, just like that. Now if I will again run this code, I will get it like this. So that is the case with inheritance here. I have commented out this because this was giving me error here. So here the work which I was doing using so many line of codes or LOCs here in oops in our last lecture, I have done it in these many languages, that I had to make this also, then this also. Now I made one class, and then I inherited that class into my another class, and then I called our function or printed our whatever I wanted to print. So I inherited that parent program here. This is called as parent program because the properties of this are getting inherited in the second class, or this is called as instance class or inherited class, or you can also call it child class. So the things are getting inherited here, and then the function is working like that only, which we did in oops. Plus, if I want to change anything, I have to just do it in one place and it will get changed. Suppose if I have to make changes in employee, so I will make changes in employee, and the rest of the places it will get automatically updated. So now you will ask, why will it or how will it get updated? So the answer is because we are making a programmer class from employee here, and the employee is our base class. This here, the class employee is called as base class. So this is the base class, and we have made programmer class from that employee class. So it will be also called, as I told you, it will be also called as parent class. And this one right here, the inherited class, which has inherited employee here in programmer class, is called as inherited class. Okay, now I'll come back here and show you what is the difference between inherited class and base class here. So we are in here. So as you can see here, the class employee here, the first class that is created here is base class, and the inherited class is like that, the second class which we made as programmer, and we inherited employee class in this programmer class. So this is our derived or child class. We can use the method and attributes of employee in programmer object, as I said. Also, we can overwrite and or add new attributes and methods in programmer class, which will automatically change in the employee class as well. Now there are several types of inheritance, so we'll talk about them one by one with writing our codes as well. Now single inheritance. Inheritance occurs when child class inherits only a single parent class. That's what we did here. So this is our single inheritance class here. As you can see, base class is derived to the child class. Now talking about multiple inheritance occurs when child class inherits from more than one parent class. Now means there will be different parents for one class. Now I want that the employee also comes in programmer, means all the attributes and methods will come inside the programmer. And I want some method and attributes from some another class also. So now let me show you an example here. Let me get here, and I will write multiple inheritance dot py, just like this. And now let's go through an example here. Now suppose here I will just copy this one here, and then I will go there and print them. Now I want them to be removed, and then I will class coder, just like that. Now class coder can be anyone coding at home at anywhere. Now, suppose I have a function or method in that class coder, and suppose that function is the language. So the language is the function there in this class coder, and suppose by default that language is Python. So let us do it. Let us write language is equals to, let's give Python, just like this. Now for everyone inside this class, we know that this language will be Python here only. Now suppose I will create a function here which will be printing our languages here. Now let's create a function def print languages, and it contains self as an object here. Then it prints what it will print out of all the languages, comma, here is your language, and I will give it self dot language here, just like that. Now what I will do here is, now I'm going to make a programmer class from both employee and coder classes here. So now as you can see here, I will just put comma here and write coder. So now the two classes are here in my programmer class as well. Now my programmer class will contain the properties of both employee and coder. Now let's make, here it is, let's copy this and now I don't want to print them, but I will just b dot show and b dot print languages and b dot show languages. This is not a function here. Now we do not have any name attribute in our programmer class. Now I'll give the name here in employee as name. Let's suppose the default name here like this, and I will not print here this. I will print company, suppose, just like this, and company is this. Now for function show languages here I will create show languages here only, so it will be now showing here. Now I will print here company just like this, and I will print this as language. Now if I will run this, I will get all this. The name is default name and the company is this. Now out of all languages, here is your language this, the name is this, and he is good with Python language. So that is how you can do multiple inheritance here in Python or in OOPS here. Now the another type of inheritance is multi-level inheritance. Now what is a multi-level inheritance here? So multi-level inheritance basically means one is a parent class, and then we will create a child class from that parent class, and then the child class will contain another child class of that child class only. So child will contain a child class. That is how multi-level inheritance work here in Python. Now in our code, let's suppose I make employee, then programmer, and then I want to make manager of that programmer as well. So how will I make that? So I will make a manager who is programmed in himself by the programmer, and the employee is also there, but a manager is also there. So program employee, programmer, and then the manager, and the manager are two child classes. So syntax will be similar as in multiple inheritance here. So I'll come back here again, and then I will suppose firstly I will create a file here, multi-level inheritance dot just like this, and go in multiple inheritance. Then I will copy this, paste this here, and I will go to suppose this only class coder. I will copy this and will paste it here. Now let's make it programmer just like this. Now I will just do a simple code here just like this. Suppose for now I will pass the value just here. I'm thinking about it what I should do here. And now let's make class manager, which will contain the properties of programmer just like this. And then what I should do here is I should get all the properties of employee here in my programmer class. Then I will give numbers here instead of pass. Here I will give b is equals to 2, then here I will give a is equals to 1, just like this. So we have our objects here, attributes here in our class. Now if I make here an object and say o is equals to employee, then I will print two things here, print o dot a, and I will print o dot b. Now let's see here what will happen here is, so o dot a is giving me the value here as 1, but when I printed o dot b, it's showing me attribute here. Employee object has no attribute b. So as you can see here, although it we say that it contains the properties and methods here, but the attributes are not contained here. As you can see, the employee has object no attribute b, so that makes it more understandable like this. If I will make another object here as o is equals to suppose programmer, here b is doesn't contain this. Now programmer contains the properties of employee, so it should print it. Now let's just move ahead to it. Now if I will print o dot a, and or just print it here only o dot b, just like this. Now will it print it? So as you can see here, again employee object has no attribute, it is giving me here. Now if I make another object here and I print, let me just comment them out here. Let's use multi-cursor property here, that will make our program more faster. So I will use hash here, and then if I will suppose I will print o dot a, then I will print o dot b, then I will print o o dot c, just like this. When I will print it, it will give me all the values, because now here it contains both the properties of both the classes here, because it is manager and it is containing the programmer properties. Now programmer contains the properties of employee, and employee is a base class here or parent class here. So when I was trying to print it here and here, so it was giving me the values or the properties which are present inside it, and the properties which are not present, they will not get printed. And you can put methods inside these classes and make it more advanced, so use cases and explore it as much as you can. So that was the difference between our uh, single inheritance, multiple inheritance, and multi-level inheritance. Now let's move ahead to another some methods here. First is our super method. A super method is used to access the methods of superclass and derived class. What does it mean? So whenever we call a constructor, suppose in multi-level inheritance like this, if I create here suppose a function, or we call init constructor here, just like this, and then I will give it suppose print constructor of employee, and when I will copy this, and suppose I will paste it here, then I will come back here and paste it here again, and now I have to change it to this one to programmer and this one to manager. So I have created some init functions here in every class here, in parent class as well as both the child classes here as well. So what was it doing here, that whenever I run the program, so it was doing it for this class and not the two classes here. Now sometimes we want that this class also run and this also run, the two classes also run, these two constructor also run. Now I want that when manager constructor will run, it should also run this our parent constructor also, and that parent constructor will also run our programmer constructor also. So for that we write here super conductor. So here I will provide it super dot in it, just like this. So what it will do is it will make a programmer's constructor will run the employee parent constructor also, and after that it will run the manager constructor. Now if I go here and give them all like this, now I put it like this, and now I want to erase them here, just like this. Now there is a mistake here, uh, now I want uh, to be this and this and this. I want to make changes here only. Now if I will run this, you can see that constructor of employee ran here uh, when I gave super init here. And if I remove them and then, so what will I get is, as you can see, in manager, constructor of employee ran here, then constructor of programmer, and then constructor of manager here. Manager doesn't have a attribute, so but it has a run our program here. So that is how you can use super constructor here. Now let's come back here and we'll study about class method. Now what is a class method? A class method is a method which is bound to the class and not the object of the class. Now what does that mean? Now that means that it is a way to access class inside a method. Suppose if I say that I will copy this and I will make class.py just like this, class method dot, you will understand this, with this, and then I will do what here is, I will remove this and a is equals to 1. Then if I will make def show self just like this, and I will ask it to print the class value of a is uh, self dot a just like this, and I will make an object here, e is equals to employee. Then if I will give a value here as e dot 45, or not like this, e dot a is equals to 45, then I will, if I will print or just call the function show just like this. So what will it show me? It will show me 45, or if it will show me 1 here. Let's see. But I want to show class value here because I have written class attribute here. So I want to show the class value, not instance value. So for that you have to create a class decorator, and instead of self here you will write CLS. So whenever you put a class decorator like this, just like in static method with it, we have to do the same thing here as well in class method. So once you will write it like this, just like what we did in static method, class method just like this. So now it will firstly I have to give here CLS also, not self. So now it will give you the attribute of class, not the attribute of instance when you will run the program. I will run this now. Oh, here also I have to give CLS. That is how you will get your answer. Now here it is showing 1, the class value is 1 as we have given in our class attribute. So what were the two things here? Self gives what? Self. So self shows us the object on which method is running, and what does CLS shows us is the class on which the sorry, not the object, the method is running, just like that. So these are the two important things here. I have written it here just like this in the comments. So that is how self and CLS are differentiated here, and class method is what? Class method will give you the attribute of your class and will ignore the attributes of instance. In normal way, instance attributes are given more priority than class attributes, but here class when you will use a class object, so and for in wherever you write self dot a or whatever, so you have to write cls dot a or whatever the variable you have given. Now you have to use class method before your function, and then you will get the value of your class attribute, not the instance attribute. Now moving on, we now have property decorator. Consider the following class employee at the property def name set. So if e is equals to employee is an object of employee, we can print e dot name to print the e name by internally calling the name function. Now what is this? We'll get into it. Now again come here, I will show you property decorator dot py, just like this. Suppose we have a class here. I can give some name. Suppose e dot name is equal to this, and if I want to print that name, I will give it print e dot name here, just like that. So what I want by doing is that I directly want to put my property here. So what will I do is I will put my decorator here, and I will tell you the use case later on, but for now let's just understand this only, and let's just understand the syntax here only. So what happens is when we put property decorator here, let's suppose I had definition and the function was name self and it was returning e dot name. As I said, this is the syntax here. For not this, for that I also need something here like this. I will get it here, then I will put it here, and then if I want to make a syntax of a property operator, how will I make it? Is I will write property just like we did in our last class method here. So what we can do after this is I can set the name here. Suppose I will use name dot setter. Name setter is created here, then again another function name self value, just like this, and it will take self dot e name as value, just like this. So you'll say that we can directly put print a dot e name. Why we are doing this again and again when we can print it using print to function only? So suppose I want to write a name, suppose Rishabh Roy, and I want to put these two names in different instances here. So firstly I want the first name and then I want the second name or the last name here. So what is happening here is, let me tell you. Now I want my user to only enter his first name and it will automatically get its last name. So how can I do that? If this is only the syntax. Now if I will create a name function here with self, and I will return self dot f name and self dot l name, just like now. This is only a syntax here, I'm not doing the code. So now I want my user to enter the first name. If I print f and l in places of first name and last name in places of f name and l name, but now we don't have any instance attribute for them. But now I created such an instance that will be used by using the existing instance. So here I use two properties of these classes here. I said name is a function which will run the same property here as well, but make it feel like a property. That means it will run the same logic, but it will make it feel like a property. That means when user will print its name as a return value, so you can keep that return value to yourself, which it was doing here when I did a name setter here. Take the value and put it in f name and l name, and whatever we are doing in the backend, it is not visible to our user. And that's what is called encapsulation and abstraction. Encapsulation is basically we put different working properties in a container, and abstraction is basically at the user end, he or she will not know what is going on at the back end of this program, so that we can hide the implementation details from use. Now let us get ahead to we have talked about getters and setters here. Now let's talk about operator overloading in Python, and we will wrap our chapter here. Now operators in Python can be overloaded by using dunder methods. Now dunder are what? Dunder are basically the methods or functions which are started and end from double underscore. As you can see, and we have seen init function, that is also a dunder function here in Python. These are called dunder function. These methods are called when given operator is used on the objects. So we will understand this here. Let's make operator overloading.py. So it has not made a file here. Operator overloading.py, just like this. Now I've created another file here, operator overloading. We'll talk about operator overloading in here. So suppose I have a class number here, and in this class, inside the class I did what is a is equals to 1 and a is equals to 2. So you can say that there is a number containing two class attributes. So what I can do here is I can make a constructor without giving these numbers, and I can say class number limit self n, and I will provide it self dot n is equals to n, like this. And now I'll make two attributes here, as I said, or two objects here. Number here I will provide number 1, and m is equals to number 2. Now if I will print the sum, suppose n plus m here. Now in Python everything is class, so if I will run this, it will give me a name error here. Number is not defined. What do you mean? What do you mean by number? So now we understand that in Python everything is a class. That is why when we print the type attribute, to find out the type of any function or any data type, when we did in the previous lecture as well, when we were trying to find out the type of that data type. So when we print them, so it was showing us class and then the data type, str, integer or anything. Firstly it was written class. So in Python everything is a class. As we want to customize the operation on the operands here, so we can do overloading methods in. So I will make a, suppose not this, I will make a function here like this. So I will use a dunder method here. How to do that? Suppose I am making another like this, so this should stay here. Now if I make another function here def, and I will use a dunder method here, add self num is what, so it will return self dot n plus num dot n, just like this. And when I will run this, so now it is showing me an error here again, that the same error. So what I can do here is, where the problem is I have not written it like this, so it is not accepting my class. Now if I will run this, I will get type a number, and number takes no arguments. So for that here, this will not be limit here, it will be in it. That is how we will create this, and if I will run this, I will get the answer as 3. So that is how you can use operator overloading to define addition, subtraction, multiplication or division, like these functions which I have shown here on them. Let's move ahead to another some functions here. As you can see, there are several dunder methods here. As you can see, one is add, one is subtract, which will subtract, mul, which will multiplicate, true division will give us the true division here, and then the floor division. Now here are two other dunder or magic methods in Python. Str, which used to set what gets displayed upon calling str object. So that is how you can use dunder method str, and then dunder method len is used to set what gets displayed upon calling len object. So this is used for string object, and this is used for length of the object. So I hope I was able to cover everything possible in this chapter, and you have understood it as well. Now we'll move forward to our practice sets of this lecture, and I'll meet you there. So now as we are here in our practice set, now let's start covering our practice sets here. Now the first question here is, create a class 2D vector and use it to create another class representing 3D vector. Interesting question. We will come here in our VS Code, and I will create question 1.py this, and then we'll start doing our question here. So firstly, let's just create a 2D vector, just like this. A class here is created, and so 2D vector will contain I cap and j cap here. So now I will create a function in init, and I will give it two values here as this and this, and now I will do it like this: self dot I is equals to I, and then self dot j is equals to j, just like this. Now I will create another class here as 3D vector, just like this, and now I will do the same thing here again, init, and then self I, j and k. So now self dot I is equals to I'll copy this only, paste it here, then I will paste it here again, and I will write it like this, k, and here also k. So that is how we have created our two classes. Now what we have to do here is, now we will create another functions here, some functions here in both the classes to uh, show the vectors when we will print them. So print f string, the 2D vector is self dot I plus self dot j, and here j cap, just like this. Now I will come back here again in definition again. I will create another function here, def show again self, spelling got wrong here, self, and then I will print the vector is self dot I cap plus self dot j cap, and then plus self dot k, and here I will put k. So that is how our functions and the attributes present in them are created. Methods in the classes are created. Now I'll create objects here. A is equals to 2D vector, and they will contain the value 1 and 2, and B is equals to 3D vector. This will contain value 3, 4, 5, not like this, 3, 4 and 5. And now I have to call a show function as well. So a dot show and b dot show, just like this, and I will make it go here and it will go here, and so I will run this. I will get the two vectors here as with their magnitude or direction as well. I will get back to our PDF here, and I will go to another question here. Create a class pets from class animals, and further create dog and pets. Add method bark to class dog. Now to do this question is not asking us to create any methods in the two classes, pets and animals. So we will not create the classes here, we will just use pass. So suppose the first class I will create here is animals, and then since it's not asking us to do anything, so I will just pass it that, and then I will create pets which will inherit the properties of animal here. Then again I will pass it, and then I will create class dog which will inherit the properties of pets. Now we will use here our static method like this, and so I will now create a method or function here bar. So not need to give self here because we have used uh, our static method, so we do not need to give here self. So now the print is wow, and then need to create an object here. D is equal to dog, not this dog, like this, and then d dot uh, bark will be called just like this, and I will run this. So it's providing me the value. Now let's move ahead to another question. So create a class employee and add salary and increment properties to it with a method salary increment. So this will be our method with a property decorator. So again with a stator which changes the value of increment based on the salary. So interesting question is this. So to do this we will have to create a file here, then we will do our question here. So what the question is asking here, we have to create several functions here to what change the value of increment based on salary, and also create a class increment to increment the properties also. Let's do this. So what will be our approach will be, first create a class employee firstly, and then suppose salary here is 234 and increment is 20 this is. Now I will create a property decorator like this, and now I will create a function def. So what was the name of our this method? This is salary after increment method. I'll copy this name, I'll paste this name here, and then I'll create a function. I will give it a self. I'll make it return self dot salary plus self dot salary into self dot increment, which will be divided by 100, just like this. Now I will create an object here. E is equals to employee, and then I will e dot salary after increment will be called here, or maybe let's just print it here like this. So if I will run this, float object is not callable in this. So I forgot that we have to create setter also. Let's create a setter as salary after increment dot setter, just like this, and I will create a function here. The increment will be self and salary, just like this, and self dot increment will be salary upon self dot salary minus 1, and then it will be into 100, just like this. So here I will remove this, and then I will do what, I will create here e dot salary after increment, which will be 280, and then print e dot increment, just like this. Or maybe let's see what will happen here if I do it like this. So I have not written e here like this, and if I will divide with 100, now see what will happen. E dot salary after increment is not defined. E is not defined here, so we have to define E also. Now I have made some changes, and I have corrected my mistakes here. All this was correct, just I need to give here this all this, and then if I will run this, I will get this salary. As you can see, firstly the increment is printed here, and then the salary after increment. Salary was 234, then increment was 20, so it approximately the value was this, and then it became like this. So that is how you can do this question. Now let's move ahead to our fourth question here. Write the class complement to complex to represent complex number along with overloaded operators plus and multiplication which adds them multiple times. Overloading operation we have to use here using complex class. So how to do this? Let's write class complex and then def init self ri and then self dot r is equals to r and self dot I is equals to I. Then let's create another for add c2 is like this, and it will return of self dot r plus c2 dot r and self dot I plus c2 dot r, c2 dot I here, comma in between them is like this. We'll create another def here as str which will take self and then it will return f self dot r plus self dot I, just like this. Now we'll provide c1 is equals to complex 1 comma 2, then c2 is equals to complex 3 comma 4, then I will print c1 plus c2 just like this. Now if I will run this, again getting an error here as unsupported operand type. So I found a mistake here, that was I was not using render method here as like this. So now if I will run this, I will get 4 plus 6 just like this. Also I need to make it complex, so I should be there. Now if I will run this, I will get 4 plus 6, and this will be a complex number here which is getting printed. The same we do here for multiplication also. We will do what we will get into c2 dot r and self dot I into c2 dot I, just like this. Now if I will run this, so for multiplication we also need to provide here c1 into c2 just like this, and we need to also change this here. Now let's suppose if I will run this, it will still give me like this. So if I need to change this, I will have to provide write another thing here, which is, so after writing everything I will show you like this, and then when I will run this, so it is giving me none here, but print should be wrong here. So I have again corrected whatever was wrong. Now if I will run this, I will get it like this, addition this and multiplication is like this. So that is how you can do this. That is how you can create complex complex expression here using operators overloading. Moving ahead to fifth question, write a class vector representing a vector of n dimensions. Overload the plus and multiplication operator which calculates the sum and the dot product of them. So I have to now give the sum and dot product. So now here firstly let's just create a class vector, then give it def init, and then let's remove this and let's write x, y and z like this, and then give it self dot x is equals to x, self dot y is equals to y, then self dot z is equals to this, just like that. For adding we will create another function or method here using again the, so I'll give it other only and remove pass here. I will be provided, I will take result here as vector of self dot x plus other dot x, then self dot y plus other dot y, then again self dot z plus other dot z. Just like this I will make a result here, and then I will return result just like this. Now creating def for multiplication also we will be used under mul, and then remove pass here. We'll again use other here, and then create result here again, just like that. The same thing here. I will copy this. I will copy this here again, but in place of addition I will add multiplication just here like this, and here like this. So now we will return our result. Now creating def and using render function str, as you can see here it is given. Now remove pass, give it provided self only, and then give it to return self dot x comma self dot y comma self dot z, just like this. Then creating objects, I will create v1 is equals to vector 1 2 and 3, and I will make copy of it, and I will use multifactorial. Here I will make it 3, and here I will make it 2, and then here also, and here also I will erase this, and I will write 4 5 6, and then this one 7 8 and 9, just like this. We have created 2 objects here, 3 objects here. Now let's print v1 plus v2 and print v1 into v2 as well, and again after that print v1 plus v3 and multiply then v1 into v3, just like this. Now if I will run this, I will get it like this only, but here since it was vector, so I have to also provide icap, jcap and kcap. So just like this I will do this, and then I will give I will get the direction of that vectors as well. So as you can see, icap, jcap, kcap is also presented there. Now let's move ahead to another question. Write str method to print the vector as follows. So this is the vector, and we have to use str function here. We are using it quite several times. We have used it in our several questions, almost all the questions. So as you already saw here, when I was not giving it these values, so it was printing it like this. Now if I will now let's comment it out and let's see what will happen. Here it is not giving me the value, but uh, if I remove this all, but if I write this, so here as you can see, our in this question only you can see that here str is used, and using str we can print those values here. So for 7 8 and 10 you can see it like this. Suppose if I write here 10, so as you can see 7 8 and 10 is where, okay, so this is for multiplication. If I go for addition only, to make 7 8 and 10 we have to let's make it 6, let's make this one also 6, and for this I will make it 7. Now that is printed. Now here as you can see 7 8 and 10 is getting printed here. That is how you can do that question as well. Now let's move ahead to our last question, and we will wrap this chapter here. So override the len render method on vector of problem 5 to display the dimension of vector. Now we have to use problem 5 here. So what was in problem 5 is what we are going to see. This is only question 5 here. So what we have to do here is, I'm just going to copy this one and I will create a new file here, question 6.py, oh sorry, question 7.py, Now I'll paste this here and remove this from here also. Then I will come here and see what we have to do. Then we have to create len function here. So let's use, or maybe just remove all of them, and let's now use for depth, then length, and let's provide itself return length of uh, so now let's just remove all of this and let's create a list only here in place of them. So for making a list, let's let's take another L here, and then if I will give a self dot x, self dot y, and self dot z is equals to L. If I will do it like this, or if I just make it like this only, self dot L is equals to L. So this will be our length function, and now let us just uh, make b1 is equals to vector and 1 2 3, then print length of uh, v v1, and here the length of this. Now let's print this. It is giving me vector dot init takes two positional arguments but four were given. Okay, so to correct this, the mistake here was I haven't given self here. Now let's print this. Again I am getting the error here. Takes two positional argument but four were given. What we can do is we can put them inside the square brackets, and then if I will run this I will get the answer as 3. So that is how you can do this question. And with that being said, our lecture 9 is over, and I hope I was able to cover every topic and I was able to explain it with crystal clear clarity. So we'll meet in the next one. Till then, thank you.